Said name the cell.
Osteoblast.
Osteoblast. And if I pointed at name this cell, bone lining cell.
I have a question.
Yes.
Aren't bone lining cells technically osteoblasts?
Bone lining cells are osteoblasts that are no longer actively laying down osteoid. Okay, so they are called bone lining cells. Right. An osteoblast, by its very nature, should be actively making matrix, and so then that's when they become these large plump cells.
And that was the osteoid layer?
Now, what it does is the first layer that it lays down is the extracellular matrix, and that is going to be the osteoid. Right? Those are your type 1 collagen, type 5 collagen, osteopontin, osteocalcium, osteonectin. And then you're going to mineralize that layer to make it hard. Right? So osteoid is the unmineralized portion of the bone. Now, if I put my arrow here and said name this cell, all right, lots of nuclei in this guy. So this is an osteoclast. Here's another osteoclast sitting over here. There's another little osteoclast sitting over here. If I pointed to the left of my arrow here and I said name this space, Haarschup's lacuna, okay, because this is an osteoclast sitting in a Haarschup's lacuna. If I put an arrow from here to here and said name the layer, zone of hypertrophy. If I put it over here and said name the layer, zone of proliferation. Over here, zone of calcification. And then if I put it over here, zone of ossification. All right? And of course, all the way up at this end here is the resting zone. If I asked you, is this a primary or secondary ossification center?
Primary.
It's a primary ossification center. I went here and I said, what kind of bone growth is occurring in this region? Endochondral. No. What kind of bone growth? Intramembranous, right? It's growing underneath the periosteum. That is a type of intramembranous bone growth, all right? Now, question that I know has been on old board exams is, does this tissue undergo interstitial growth? And it sounds like a trick question, but remember that a feature of interstitial growth is that the tissue can grow larger by interstitial growth. Chondrocytes, when they divide and they start secreting extracellular matrix and it then starts adsorbing water, that cartilage gets bigger in dimension, right? Will this bone, if you fill up these spaces, will it get bigger? No. So bone cannot undergo interstitial growth, all right? So does this tissue undergo appositional growth? Absolutely, because intramembranous bone formation under the periosteum is a form of appositional growth. Okay. Trick question. If I said name this structure, Volkmann's canal would be very good. Okay. Now I say it's a trick question because quite frankly it could just be a flattened out Haversian canal. So But the fact that you know that the Volkmann's canals run perpendicular to the Herversian canals is good. If I put a circle around this and said name this structure and put an arrow across it, name this structure, osteon, and the other term for that is Herversian system. All right. If I put the pointer here and said name the space, Herversian canal. All right. Put the pointer here, name that space. It's a lacuna. What kind of cell resides in this space? Osteocyte. Name this space. Canaliculus, canaliculi. All right. What is the function of this space? Right, there's a whole lot of different functions, right? It facilitates communication between cells, it holds fluid, it holds the filopodia of cells, right? But all of those are what that space is doing. Connecting lacunae is another thing that that space is doing.
What is it? Gap junction?
The filopodia.
Then if I said name this layer, interstitial lamellae, okay? What type of bone is this? Mature bone? Compact bone? Dense bone? Osteonic bone? Lamellar bone, all right? Any one of those would be correct.